If you enjoy my videos, please check out my website at creationsciencefiction.com, where you'll find articles on creationism, science, and my blog. If you really enjoy what I'm doing, please consider becoming a contributor at the link in the video description. This is a continuation of my last video and my discussion with Dr. Antoine Bret on Kevin Conover's course on young Earth creationism. In this video, we're going to cover his arguments about magnetic decay, receding moon, and the lifespan of comets. Dr. Bret has also written a book called The World is Not 6,000 Years Old, So What? And it's available on Amazon.com. I'll put a link to his book in the video description.
Let's move on to another limiting factor. Magnets lose their strength with time. If you've ever had a magnet on your refrigerator, over time that magnet will stick less and less and less. Pretty soon it will fall right off the fridge, it becomes useless. Magnets lose their strength over time. The Earth's magnetic field is getting weaker. It can't be billions of years old. Based on the rate at which the magnetic field is decreasing, it's a 25,000-year max age. In fact, the strength has declined 10% in the last 150 years and 40% in the last 1,000 years. We're losing our magnetic field. Now, this isn't a good thing. The magnetic field is what protects us to a certain degree from damaging rays from the sun and from other things. It also affects our tides and affects our relationship with the moon. And so we don't want to lose that magnetic field, but the reality is, from a biblical creationist perspective of a young Earth, 6,000 years old, it makes sense that we still have a magnetic field. But if the universe and the Earth is billions of years old, like evolutionists claim and old Earth proponents claim, then we shouldn't have a magnetic field at all. And yet we still have one.
All right, well, even I know that the Earth's magnetic field is not constant, and no one's ever claimed that it's constant. We have evidence that throughout millions of years it's changed, it's reversed. There's absolutely no one claiming that it's constant rate, so this is a terrible argument.
Just a parenthesis. In the bottom of the slides, of his slides, he has some pseudo-scientific references. Usually, most of the time, extracted from so-called creation science journals.
Okay, right. Well, yeah, he's
something really interesting. I've done this. It's really painful. If you go to any science journal, for example, I'm an editor of Journal of Plasma Physics, so you can go there and check. You have the prerequisite for the authors. And creation science journals, one of the prerequisites is that the article comes to YEC conclusions.
Right.
But that's they clearly stated. And so it's kind of strange, in the honest world of honest science, this is called fraud.
Right.
Imposing the conclusion. But they do this without any shame. So I just wanted to stress that because I couldn't believe it when I saw it, but yeah, it's true.
But I've also looked into like you said, if you want to submit an article, what you have to agree to, and it's just like signing up to work for Answers in Genesis or something. You basically have to agree first that your conclusion is going to be that the Earth is 6,000 years old. You cannot vary from that, So it's not a scientific journal at all, and even though they pretend and they try to make it look like one. So,
but again, I guess that people who are not in the business can just believe, it looks serious, there are references to scientific journals and all that. So it's they completely created a parallel fake system just to be able to show off to people and all that. But so here, I'm not going to talk that long because it's more geology and it's not my field and all that. But I have a few data about this because, just going to talk origin of, I don't know if you know Ken Volgemuth.
Yeah, I do.
Yeah.
Yeah, I personally met him here too. So yeah.
And so recently, he gave me on Facebook. So I'm going to share my screen, that plot. Share. So can you see it?
Yes, go ahead. Yep.
So it's a plot of the magnetic field of the Earth up to or down to 20,000 years before present. And what's really, really, really irritating is that our dear educator talks about the decrease of the field in the last 150 years and in the last 1,000 years. I don't know if you see 1,000 years is just this first peak here. You see my mouse?
Yeah. Okay.
And they decide they can go back in time as much as they want.
Right.
In spite of the same data telling them, no, you can't.
Right. So he's going to start. He's going to start with the last peak, and then he's going to work his way forward from there. He's not going to look at the overall trend going back tens or hundreds of thousands of years. So
it's. I'm going to stop sharing. It's exactly like saying, cancel. So it's exactly as stupid as saying, the tide is rising now. So 1,000 years ago, the sea was in the middle of the Atlantic.
Right. Yeah, I hear the same thing in other geology arguments where people talk about the continents eroding. Well, you know, the shoreline of Texas is receding at a foot a year or something. It's like, so what? You know, I mean, it doesn't mean that it's receded like that for the last 10,000 years, 100,000 years. I mean, you know, you're ignoring everything we know about
and so
plate tectonics.
The 2 point I just wanted to make here is that first, they use what they hate, which is what they call uniformitarianism. The assumption that in the past it's been the same. So they don't have any problem using it for them.
Oh, okay.
And the second,
good point.
Oh, it's been like this since 1,000 years. So what about 10,000 years before? We extrapolate. Well, how do you know you can extrapolate back in time?
Right. But
so
you know, the uniformitarianism says the processes are the same now as they were then. It doesn't say the rate of everything happening today is the same as it was then, you know. So.
And the second, so first, they without any problem use something they accuse everyone of using.
Right.
And first, they use it in spite of the data clearly showing otherwise.
And they use it incorrectly, actually. Yeah.
So. I don't know. The plot can. Actually, he didn't give it directly to me, but he posted it on a Facebook post.
Okay.
About this. I wonder. Okay, how, did he see it? Did he see it? Because it's really like I purposely decide to talk only about the part of the curve that I like.
Right.
And then forget about all the rest. And you know, in climate science, deniers do exactly the same.
Right.
They say, oh, look at 98, 99, and 2000. Oh, it's decreasing. There's no warning.
Right.
So let's zoom. And so it's so frankly, these guys, they should be, as Christian, they should be honest.
Right.
Let's talk about the moon as a limiting factor. Now, the moon is pretty awesome, but it's moving away from the Earth at a consistent rate. Now, for those of you who like romantic dates, this might be a problem because the moon is going to be getting smaller and smaller, and pretty soon it'll just be gone. No, I'm just kidding. Don't worry. In your lifetime, the moon is not going to disappear. You're good to go. You can still have romantic dates. But we are losing the moon slowly but surely. Now, the moon is what causes the tides. As the moon rotates around the Earth, it pulls the oceans toward it, and this causes our high tides and our low tides. It allows the water to mix around, keeps the temperature of the Earth at a good temperature, the waters at a good temperature, mixes the warm and cold waters and the minerals in the ocean. Now there's something called the inverse square law, and what it says is the force of attraction between two objects is inversely proportional to the square of the distance between them. Well, what's the significance here? Well, if the distance is 1/3, the force of attraction between two objects is 9 times greater. So what this means is as the moon moves closer to the Earth, the force of attraction is going to exponentially increase. Why is this significant? Well, if we go backwards in time, if currently the moon is moving away from the Earth, then that means in the past the moon was closer to the Earth. Well, based on this, the maximum age for the moon and the Earth system would be about 1.2 billion years old. Otherwise, you would have the moon hitting the Earth. So you can't have the Earth-Moon system be 4.6 billion years old like many evolutionists argue that it is. They would be hitting one another at the rate at which the moon is moving away from the Earth. And that might explain what happened to the dinosaurs. If you took our lesson on dinosaurs, you know that there are theories out there about an asteroid hitting the Earth and killing all the dinosaurs. There's theories that the dinosaurs actually, their methane that they produced actually killed them off. But maybe what happened is they got mooned. As the moon was traveling around the Earth, it hit all the tall dinosaurs and wiped them out.
All right. Well, it's almost the same thing as what he's doing in the last thing, where he's looking at a very short time period, like I don't know how many years he's going back, saying that it's a constant rate. But saying it's a constant rate right now, when you're looking at a tiny fraction of it, it doesn't mean that it was at the same rate a billion years ago. So,
oh yeah, it's exactly the same business. I choose a time window that I like, and then I extrapolate back in time. But because of tidal friction, the moon is receding and the Earth's rotation is slowing down at rates too fast for the Earth to be billion years old. So again, it's impact. Oh, that's a tricky one, because impact is a Creation science journal, but just by the title, you cannot tell. So they really dissimulate here.
Okay.
And then you have all the explanation. Well, of course, no, you cannot extrapolate back in time. And there are a lot of references of people who are working for real, doing an honest job, and who found definitely evidence, because the length of the day and the tidal friction has an effect of the moon distance and the Earth's rotation. And there are evidences that the rotation in the past was not the same. So they decided that they are going to extrapolate back in time because it suits them. But when you look at the data, you find first that's an assumption. So please, if you make an assumption like this, just not prove it, but just give me some reasons why you can make this assumption. And when you look at so you can say, oh, the tide friction has always been the same. Well, no, it hasn't always been the same. Be it, for example, because they explain we went to Tokyo, for example, because the tidal friction depends a lot of how the continents are arranged. And when you look, I don't know, it's 200 or 300,000 years, 300 million years. You had Pangea, one big continent, and so the tidal friction is not the same. So yeah, people are looking at this,
right.
And something which so yeah, again, they assume exactly what they want to assume without any justification.
Let's talk about comets as a limiting factor. Short-period comets are losing material and have a life expectancy of less than 10,000 years. Now, I interviewed an actual astrophysicist on this issue, and he did his dissertation in order to get his PhD, this is Jason Lyle, on the fact that comets die out. He literally was following a comet that when it passed around the sun, it never came out the other side because it died. Comets die, the material that's coming off of them is them breaking apart. They don't last for longer than 10,000 years. Why is this significant? Well, the reason is because short-period comets should all be gone. They shouldn't exist anymore if the universe is billions of years old. Because the theory is that the comets came about when the Big Bang happened. If the universe, they came about from the beginning of the Big Bang or somewhere close to that time, there's no way they can be billions of years old. They only live for 10,000 years. We should see no comets in space, but yet there they are. If the Earth is only 6,000 years old, as the biblical chronologies indicate, well, then it makes a lot of sense that we still see comets.
Okay, well, comets, he says, we think were around since the Big Bang, huh? That was pretty interesting.
Yeah, no, that's...
Wow.
Yeah, so several things about the short period comet. First, Jason Lai never published anything on comets. So maybe he's been interested in comet or whatever, but when you do your PhD on something, you publish on this something.
Right.
It's really easy to find peer-reviewed publication of Jason Lai. There's nothing on comets.
Except maybe in a journal of creation or an article on a website, but we're talking he never published.
But he's stating that he was doing PhD on comets. Well, maybe he was interested in comet, but he wasn't doing the PhD on comets. He was doing the PhD on solar physics or something like this. So maybe in the course of his work, he looked at a comet or whatever.
Okay.
You frequently have comet plunging into the sun, and that you can easily Google this. But Jason Lai never published anything on comets. It's interesting because there is an interesting parallel with the longer period comets. There is around the orbit of Pluto or Neptune or whatever, what is called the Kuiper belt.
Mm-hmm.
So which was hypothesized in 1951, not just as a reservoir for short period comets, but as a remnant of the formation of the solar system.
Right.
And it was found in 1992, the first object from this belt was found. And now they spotted more than 300. So yeah, it happened. You see that there is a connection with the next topic. It happened tons of times in history of science that you make the hypothesis of something exists and then you find it.
Well, what he's doing here is saying these comets shouldn't be around this long because they die out in a short period of time.
Yeah.
But what he's saying is, and he's going back to the Big Bang. I don't know why he got all confused there. I mean, we're talking solar system. We're not talking the formation of the universe.
Oh yeah, completely.
The other thing is that these comets, they're nudged out of their orbit, and then they become a comet. They're not comets out there right now. All these short-term comets, like you talk about, they haven't been comets since the beginning of the solar system. They were something orbiting in this belt, ended up getting nudged out of their orbit and then headed towards the sun. And this could start happening now with another event that would start that happening. It didn't start at the beginning of the solar system. So he's just way off here. And the whole argument about the comets is ridiculous.
And he doesn't even talk about the Kuiper belt, because now that's reality. And so, yeah, that's a belt of mess around, I think, Pluto, Neptune, or whatever. And through any gravitational collisions or whatever, you can kick out someone from this belt and it just starts orbiting the sun.
Right.
So you have an infinite reservoir of, and it doesn't even mention it. Now, I can tell it now, but after we are going to talk about a long period comet. For the long period comet, there is also an hypothesized reservoir, which is the Oort cloud,
right,
which hasn't been observed yet. And then he talks about it. So that's, again, really misleading. If the reservoir has been discovered, has been spotted, I don't talk about it. But if it hasn't been spotted, I talk about it.
Right, right.
Besides the fact that, as you tell, the first time I listened to it, I didn't even notice the reference to a Big Bang, but the guy clearly doesn't understand anything. And it's called, the website, Educate for Life. That's really bullshit. I mean, there is a verse in the Bible, it's James 3:1, saying if you want to be a teacher, you better be careful, because you're going to be judged more severely. And what he's doing is incredible. I mean, I would never dare teaching anything with just a low knowledge.
In 1950, based on a study of the orbits of several long-period comets, the Dutch astronomer Jan Oort proposed that a great spherical shell of comets existed at the remote frontiers of our solar system. Now, did he have any evidence that this shell or this spherical shell of comets existed? No, he had no observable evidence. He had no repeatable evidence. He had no testable evidence. It was just a hypothesis based on no evidence, an assertion to try to make sense of evolutionary time frames. Many scientific papers are written each year about the Oort cloud, its properties, its origin, its evolution, yet there is not a shred of direct observational evidence for its existence. Now, that wasn't said by a Christian astronomer, that was said by Carl Sagan, very famous atheist astronomer, who says there's no evidence at all for the Oort cloud.
So yeah, it's interesting first because, as I said, the Kuiper belt was an hypothesis until 1992. The Higgs boson was an hypothesis until 2000, I don't know what. I mean, the list is super long of stuff that's been hypothesized.
And you know, Sagan is, when they're talking about evidence, he's talking about direct observable evidence as far as actually seeing it. We know we haven't seen it, but the comets themselves are the evidence. I mean, you know, there's a cause and effect there that they're looking backwards to, and that's why they're hypothesizing it. It's not the first time we've hypothesized something like that and found it later on.
So something also he doesn't say about the Oort paper, which each time I talk to these guys, apparently no one ever read it, although it's free, it's on the web, is that the reasoning of Oort is that these long-term, long-period comets, their orbit is unstable, something like this, with a time scale not of a few thousand years, but of a few million years. So even if there's no Oort cloud, according to the Oort paper, it doesn't tell you the solar system is 6,000 years old. It tells you it's a few million years old. But that never comes up. That never comes up. And again, there is this business that, oh, we haven't seen it, so it doesn't exist. Well, let's look at the list of stuff that were hypothesized and that we found. There's a huge amount of as well. So I completely agree with you. If we see this comet falling, is that they fall from somewhere. Now, what these guys are going to tell you is that, oh, you said this because you assume the system solar is old. And here also there is a kind of younger creationism rhetoric. It's not repeatable, it's not observable, it's not blah, 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 blah. Each time they are cornered, they jump on, well, it needs to be super repeatable, super observable, here, now. So suddenly they become super strict. And for example, astronomy is not going to be a science because you are not going to repeat it in the lab. So it's an indirect
and your hypothesis, or what you use to support your hypothesis has to be repeatable. I mean, it doesn't mean that we have to repeat Pluto going around the sun in order to know that it happened. We have to project the orbit. Now we have to look at the time frame, and that needs to be repeatable. That data has to be repeatable so we know it's correct. We don't have to repeat the actual physical orbit of Pluto. And that's the type of thing that they kind of say, well, you can't say the Big Bang is scientific because you can't repeat it. That's not science. That's not the way science works. You don't understand science.
So they also came up with this pseudo distinction between historical science and observable science. Sure, you heard about it.
Yeah. Oh, yeah. The Cole Kenham.
So you can observe the past. Yes, you can. You observe the sun right now as it was 8 minutes ago. So you are observing the past, literally. So when you observe the moon, it was there 1 second ago. And when you observe Eta Carina, I think it's 7,000 years ago or 9,000 years ago or something like this. So yeah, you can perfectly observe the past. That's so in conclusion, I would say that I don't understand how someone who possibly in the rest of his life is really rigorous and honest can become this kind of intellectual pirate. Just shortcutting everything, forgetting the data he doesn't like, pontificating obviously of something he doesn't understand at all. He plugs the Big Bang everywhere. He doesn't understand the horizon problem. He has a whole lot of data wrong. Just factually, this supernova business is incredible. Just check, and that's it.
Yeah.
So it's depressing.
Yeah. Well, thanks for joining me today.
You're welcome.
I've known you on Facebook for a couple of years. It's great to talk to you in person. So
great.
That's going to wrap it up for this video. Thanks again to Dr. Antoine Bret. In the next video, we're going to cover things like the geologic column, circular reasoning, radiometric dating, and why are there no trees older than the biblical flood. So stay tuned for the next in the series on Kevin Conover's online course for creationism.